Hey, everybody. Welcome to Skydio's webinar, co hosted with the Arkansas Valley Electric Co-op. Today, we're going to be talking about strategies to avoid downtime and cut inspection time by about 50%. My name is Angad Singh, and I will be your main host for the webinar today. I'm the channel sales manager here at Skydio, so my job is to manage the partners that sell our product into the field. You may have seen me on a webinar before. I've been doing these for a while now at different companies around the UAS industry. My background's in photogrammetry and remote sensing, and I've kind of made my way through to being a partner manager here now at Skydio. I've been at Skydio about 9 months. Um, Today, I'm going to be the main host, but I'm not going to talk that much because we're really going to focus on our co-host and our guest speaker today. So Corey Hitchcock, he joins us now. He's new to Skydio. He left the utilities industry where he helped grow one of the biggest drone programs at Southern Company for utility-focused inspection, to now be here as solutions specialist for the utilities industry at Skydio. And I'll let Corey introduce himself for a bit. So Corey, go ahead and tell the world why you're here at Skydio and what you're excited about.
Hey, I'm Corey Hitchcock. I am excited to be here at Skydio. I am the utility solutions specialist, as Angad mentioned. I am kind of the serve as a bridge between the utility community and industry and Skydio proper. So excited to be here. Excited to hear what Levi's got to share.
Yeah, absolutely. No, we're really excited that Corey joined the team. I've had the pleasure of working with Corey in the field when he was at Southern Company. And it's pretty exciting when we can get experts from the industry to come join a company like Skydio and really help push it forward. And so, Levi Young, you're a GIS analyst, and I'm helping run the UAS program at Arkansas Valley Electric Co-op. You've been doing it for a couple of years. You're helping implement some really cool technology and kind of pushing the boundaries. I think in the last 2 or 3 years, we've seen significant growth in the industrial side of drones, but a lot of it has been pushing use cases that we've kind of built over the last 10 years and pushing those for growth. But I think what we're going to talk about here today is something a bit novel. It's new, and it's something where you're really pushing the boundaries of what's possible, and allowing your company to innovate. So if you go ahead, tell us a bit about yourself, tell us a bit about Arkansas Valley Electric Co-op, and then let's hit this off.
Yeah. Hi, I'm Levi Young. I've been working here at Arkansas Valley Electric for almost 5 years now, and been a certified pilot for at least 4 years. I think I got it about 6 months after I started here. As Arkansas Valley Electric, we're a not-for-profit that was founded in 1937, and our UAS program was founded in 2017. But as a cooperative, our goal is always reducing outage time, whether it be for asset fault or a storm, making safety our number one priority, and then reducing costs because everyone wants to reduce costs. Personally, my goals are always to innovate and to push the boundary on what we can do, and especially in the drone world. So that's why we started looking for these different ways to up what we were already doing in our company.
All right, Levi. So let's talk about some of the critical inspections you guys do with the drones. What are you using drones for, or what have you been using drones for in the at your co-op?
Yeah. So we have been doing distribution inspections for a while. We started out with transmission line inspections, and those go over great. Same thing with distribution. Device inspections are a big one, making sure asset health is always at its peak so we don't have as many outages. But when we do have an outage, whether it be storm related or asset health related, a lot of times we're called on to go out in front of the lineman. Let's find the damage, find where things are going wrong, report back, and that way they have exactly what they need and know exactly where to go before we ever get there. The last thing, and kind of what we're going to talk about more so today, is substation measurement and substation inspections, mapping out the substation and being able to update spec sheets or just get sizes on things, or even asset health again, because a healthy substation is going to keep everything running better.
So this proactive outage inspection that you're doing, is that more like to help you guys manage your momentary outage situation? So like the better understanding you have of what your system's doing, the better you guys can manage the momentary situation? nuisance
Yeah,
outage.
and I think that's a big thing that a lot of people don't realize in not only the drone world, but just in electrical world or all utilities in general. If you're keeping up with asset health ahead of time, the proactiveness of it, it's going to make it better in the long term. You're going to have less of those outages. So the more frequently we can keep up with inspections, the less time that we're going to have people out of power or in other utilities just out of whatever they may serve their members.
Cool. So, so tell us how you used to do it when you first started using drones before you used the Skydio 3D scan method we're going to talk about later. So, what were you guys doing when you went to inspect a substation or transmission or distribution line?
Yeah. So, whenever we were wanting to map a substation, typically, like I said, we were looking for spec sheet updates or something like that because maybe the spec sheet was damaged or it was illegible or it hadn't been put into digital yet. And we're trying to update things before we move over to digital, things like that. We're wanting to get a size comparison of the whole substation. So as you can see on the pictures here, we would put a stick or a piece of PVC pipe with some markings on it for measurements, and we would know the size of that object and put it up on a long stick next to the power grid, whatever it may have been at the time. In this case, an insulator. And this one was offline, so no power here, so it wasn't a big deal that it was right there next to it, touching it. But we're able to take pictures of the entire substation. We took thousands of pictures, and it took about a day to take all of these pictures just flying. It took several people. I mean, there was a few of us pilots, and then there was a few linemen, a sub tech, maybe an engineer as well. And we had to do all of this gathering of information. And then after that, we still had to have somebody come back to the office, take all of those photos into a PDF viewer or a photo viewer, and take that measurement that we know of that stick or that piece of pipe, and we're able to tell our sizing of insulators or bolt patterns or whatever it may have been that we were wanting to get. But they had to do it for every single picture, and if they ever needed to go back, they had to go find that picture through thousands of pictures.
Right, and so you using the traditional method that you just described was a manual capture of the whole asset, right? You're manually operating the drone, manually flying it, and doing the capture.
We manually piloted, and then somebody had to hold the stick during it as well. So that gets pretty tiring. I don't know for those people that have used those. Those are not the lightest of objects, especially whenever they're 40 foot in the air above you.
Okay, cool. All right, so now tell us how you were able to do it using that Skydio 3D scan. Like how did that make your capture faster? How did that improve your workflow?
Yeah, so it really changed the entire game for specifically the substation purpose, and that's kind of what we were looking for anyway, because we went from having to have several people there, whether it be pilots and linemen and stuff like that. Now I can go by myself and fly an entire substation without anybody there. We tend to keep a sub tech or an engineer there just in case. It's always best to be safe on these types of things. But 1 or 2 pilots may be necessary for an inspection like this, but that's about it. And I can go out there, I can put the drone down, let's send it up into the air and say, okay, here is this object, here's this object, and here's this object. And then it goes and scans every single one of those on its own. And I don't have to touch the controller after I say go. I just have to maybe change a battery or two throughout the process. It's not really, it's a process that's so easy. Almost anyone could do it in a substation immediately.
That's cool. Angad, you had some questions about EMI and the obstacle avoidance with the Skydio, or you had some comments there?
Yeah, absolutely. I mean, so this is one of those moments where, dealing with this in the field and, Levi, having met you in the field and, kind of helping that journey of getting your team Skydio drones, what we've seen is a lot of folks are inherently worried about flying in electric environments, right? And in areas where, I mean, you're flying this drone in this GIF here is flying in a live environment where that substation is not turned off, right? And I think that this is a great time to have a little bit of a discussion with Corey and Levi about how that is and flying traditional drones into flying Skydio, right? For those who don't know out there, Skydio drones are fundamentally different. They have 6 cameras on them that see the whole world around it. And every moment it's building a real live 3D model of everything that it sees. And that AI on board fly. It's obstacle avoidance based off vision, based off navigation, right? And so we're in that energized environment and we're flying these drones. And how is the drone not getting confused, right? I mean, we sometimes say Skydio drones are immune to EMI. Corey, in that energized environment, you've been flying these drones. Levi, you've been flying these drones. What's your experience with traditional drones in the industry and then moving to the Skydio platform in this specific use case?
So for us personally, over the years, and sorry, there's a mower going around outside. Couldn't have come at a worse time, but it's we in the older drones, if you even went around a transmission line, you would start to lose signal just from any electromagnetic interference, no matter what. But yes, in this video, this is a live substation. I was able to I wasn't even able to. I pushed the button and the drone was able to fly on its own, and we never lost connection. We were able to view pictures of it, view the model it was making at the time, or at least the bulk of the model, so we knew it was gathering plenty of data on what it needed to see. And it never even thought about hitting a line. I mean, it dipped and dived. It went between bus lines, highly energized, no problem at all.
Yeah, no, I think that's something that's pretty, a technological advantage with this type of solution is that camera is seeing all the world around it and allowing it to fly in that energized environment, and the drone's not getting confused and the drone's not crashing. And that's something that's pretty special, right? And that's why we're talking about a novel use case here with flying in these energized environments. So I think this is really cool. And, let's pop up, let's talk about what you're actually doing with that 3D model and what it looks like.
Yeah. So once we took the scan in about 2.5 hours for the whole thing, we were able to push it over to GNX Labs, which is a software that we use. And it takes about 24 hours for the process of this substation. It is a smaller one, but most poles and things like that don't take near as long to process. And of course, a bigger substation is going to take longer. It's just more data. But we can always refer back to GNX for these. So we can just go into this model and double click onto a picture. So it's super simple that way. We're able, just in flight time, to take this from a day of flying to just 2.5 hours. And it gives us so many different uses rather than just the measurements. We're able to inspect asset health, make sure we're maintaining our substations or our poles, whatever it may be that we're inspecting. We're able to do all that through this as well. And we can use GNX to tell changes over time during this type of thing as well.
Okay, super cool. So basically, just to clarify for some of the audience out there, you're getting out there, right? You're taking your drone out of your box, you're putting the battery in, you're looking at that asset at that substation, and you're going into 3D scan mode, and the drone's taking off. And then you're basically flying around the substation. The drone on board is understanding the volume or the object that you're about to go fly, and then you're pressing go. And now this drone's zooming around that, energized substation, taking hundreds and hundreds of photos autonomously, avoiding all the power lines. And there was a question in the chat here, what is the thinnest object that Skydio can avoid? And you can think about it about 1/2 inch. So as long as, a power line or an object or a thin branch is thicker than 1/2 inch, you're good to go. And the drone will avoid that because it's seeing everything around it. So while it's seeing everything around it and avoiding stuff, it's simultaneously taking photos from anywhere from 3 feet away to 10 feet away from the object. So it's taking these super high resolution photos of the entirety of that substation. And then the drone's landing, you're taking that SD card out, you're putting it in a GNX Labs or whatever photogrammetry platform you choose. I mean, here we're talking about GNX Labs. We're about to show that digital twin. And then you're going ahead and you're pressing process, and then you're getting this beautiful point cloud. And, my background's in photogrammetry and doing this type of work. And when I look at this point cloud that we're about to go through, I've been pretty amazed by it, right? And that's because traditionally capturing point clouds and creating digital twins of objects that are super thin and long, like power lines, that's been hard because the traditional methods of image capture are flying 100 feet or away from that object, that volume, that thing that you're interested in mapping. And here with Skydio's 3D scan, because the autonomy is allowing you to get so close and doing it by itself, you're taking photos from, like I said, anywhere between 3 to 10 feet away. And so you're getting a higher resolution photo closer up to the object that you want to map, which is this energized substation, and that's allowing us to get this beautiful 3D model. So I'm going to turn it back to Corey and Levi, and let's hop into the 3D model and let's examine it, and let's talk about what we're really using it for and the value to the engineers and to the electric co-op.
Yeah, for sure. And one thing I wanted to add to that, we fly around our copper lines as well that are even thinner, and it's not had a problem seeing those in good lighting as well. So let's hop over to that model. So can you guys see the model now? Everything's good.
We got
here?
it. Yep.
All righty. And we had a couple points we looked at here and some things we were able to kind of get out of this. We'll hop over here first.
Yeah, just so everybody understands, we use 3D scan or Levi used 3D scan here to scan the substation pretty fully autonomously. So that basically you create the boundaries of the volume that you want to scan, and you hit go, and the drone does the scan. And this model was what was able to be created with it. And we've got about a few things that we want to show you. And Levi, let's start with those insulators that we saw.
Yeah, for sure. And right up in here, one thing that was really amazing was we're able to get the geometry out of these insulators. Typically in photogrammetry, you get a cylinder. So it's incredible that we could see the spots between these and the differences. You see a couple of holes here and there, but that could be maybe we didn't get a good picture of one angle, or maybe a shadow hit it wrong, something like that. But for the most part, beautiful on all of this. And we can double click in here just if we're looking at inspections, just to make sure of the health, no tracking on our insulators and things like that.
Yeah, and that spot that you clicked on the 3D model is then referenced over to the 2D photo that was used to create that model. So you're able to get the full resolution image and be able to kind of inspect those insulator pins and really get in there and view your asset.
Yeah, and it's we can annotate the image just as well as we can annotate our model here. So we can mark spots that are damaged or anything like that as well, and we can slide through to different pictures and different angles on this as well. So it's really helping for inspection purposes and whatnot.
Yeah, that's pretty cool. So take us over to what we found on those lightning arresters there.
Yeah. So over here, we were able to find that on these arresters, and you can see it's come up down here in the corner on this angle of the picture, that we're missing a squirrel guard there. So we got to looking at all of these, and we noticed, gave me a bad angle that time. Let me see here. Might have misclicked. There we go. And you can see that on all of these, it's either damaged or it's been missing altogether. So we're able to go out and have that fixed and make sure everything's safe, and for us and the squirrels, of course, or other wildlife.
And then finally in this model, we've got a measurement of a high side switch that you did. Can you kind of talk us through that?
Yeah, and this is one of the main things that we were looking at whenever we were doing it. Because we wanted to be able to measure for, like I said, the spec sheets and things like that, or for future builds to say, okay, this substation was built this way and we want to go from this point and build into a new one, but we know we need the same sizes or things like that. And we're able to do things like bolt spacing here. You can see I was able to take this polyline and measure. We know 0.452 from that bolt to that bolt, 3 foot from the inside here to the inside here, roughly 3 foot, roughly 0.45 is again about 0.1 or almost a foot between these two on this side here, you can see. And then again, so we can assume out of this that all of these are the same bolt spacing of a 0.45, which is about 5.5 inches. And there's 3 foot in between these two and about a foot in between those two. And that way we can kind of know which ones we're looking for whenever we're going to order new things. As you look here on the length, you can see the length of the entire thing. It's about 5.5 feet. It is that 462 is going to be about 5 foot, 5.5 inches. And we know that. And then we can come back and see the actual width. And one thing that we had talked about, Corey, we know that's a 6-inch across beam, and it's showing that it's exactly half a foot, because you can see here that's all shadow over there. So we know from there to there is exactly 6 inches going across.
Which is pretty cool, which gives you confidence in your other measurements that you made on your 3D model. If you take a known measurement,
yes,
from the model, knowing that's a 6-inch piece of steel, and be able to infer or confirm that the other measurements are good.
And that's another thing you can do. Like we did that piece of wood before, or that piece of PVC pipe. You can do the same thing. I mean, measuring concrete on the ground, if you know the size of the concrete or size of a 2x4 or something like that, you can measure off of that. So you can have a guaranteed measurement and know exactly what your area of leniency is.
That's super cool. By the way, hey, for all the attendees out there, keep your questions coming. We see them. We'll address them as we get towards the end of this webinar. So we really appreciate you being active and engaged and asking questions. And I know we had a couple questions just come through about accuracy, right? What's really interesting when I'm hearing this discussion between Corey and Levi here is they're saying, hey, we know that beam is about 6 inches across. And so when we show in the measurement that because we know what it really is in the real world, we're able to use that as a reference in the 3D model in this digital twin to show that it's accurate, right? This isn't, survey grade work that we're doing with drones where we're going out there with, high precision GPSs to really ground truth the measurements in the entirety of this model. It's different because this is a substation. These are known parts and known locations, and there's traditional lengths, right? Levi, we had this discussion earlier where you were saying that most of the measurements already because they're pretty standard through that substation-like environment. So by going in and measuring a known reference, that, hey, that's pretty tight, which means that if that's pretty tight, the whole model's pretty tight. And now you have some pretty good measurement capability that you're able to make through there.
And the incredible part is none of this was done with an RTK system, and we're still able to find this.
Right.
So, okay. Hop back over here to the.
We had a real quick before you go to the next one. We had a question from Douglas Smith about, can you measure that vertical clearance where the measurement will snap to the ground? I'm pretty sure that's a feature or function inside GNext where you can measure.
It can be terrain clamped and vertical as well.
Yeah, that's pretty cool. All right, go ahead. I'm sorry.
You're fine. Okay, so let's hop back over here. Back to the slides here. This video was shown on a LinkedIn post. Some of you may have seen it, and it was the first time we'd ever flown the Skydio around live lines, and it's the first 3D scan. The first time we ever 3D scanned a live line, and it's a electronic recloser bank, 3 of them, and we can just kind of talk through it. I guess you can hear myself and my supervisor talking about how nervous it's making us because we surrendered control one time, but it wasn't around live wires. There was no wires on the pole at all. It was a climbing pole just for training linemen and things like that. So this is a really cool one.
It's making me nervous.
You can hear me.
Remember how I told you that I was kind of scared of it?
He hadn't been around it at this point.
It is a terrifying thing to surrender the control
pole and things like that. I did all the testing.
Good thing is if I'm videoing it and it wrecks, I got it on video.
And it did speed up here. It isn't real time right there.
Right?
It's flying around. We sped it up just for time's sake, but it took several. I think it was over 500 pictures at this point.
I think it's doing fine.
And we can
It's making me nervous.
go ahead and hop over to the actual model of this again. Let's see here. So this is the model that came out of that scan. It came out amazingly. One of our favorite models because you can see all of the jumper wires, the bypass switches, everything looks amazing. And we can still do that same thing where we can click in, see the actual pictures. And Corey, we kind of talked about it earlier.
Yeah, we got squirrel guards on those lightning arresters.
The squirrel guards are in place and they're healthy.
Yeah. Yeah, this is a pretty cool model because with this model and the 3D scan, you can clearly see the status of the recloser, that it's online. You've got your line and source side disconnects closed, and that your bypasses are open.
Everything's good.
Yeah, it was this. I was pretty impressed by this model.
And once again, I mean, the geometry of the insulators up here was impressive on all of them.
Yeah, being able to see those sheds. And then if you click in on the sheds of that insulator, you can get a pretty decent view of the polymer up there.
Yeah. And you can get, there's several angles of every single piece. So
yeah, you can see that you've got your cotter pins installed there on that last view you had. Got your cotter pins installed in the hot and dead end of that insulator. So that's pretty cool.
Yes. It's really changing the way we can inspect these things. And one thing we haven't really talked about that we might want to is the settings used on these two models.
Mm-hmm.
For the substation, we were using an 85% overlap and a 85% side lap, and we were 12 foot away for the pictures. So it wasn't even that close, and we still got a beautiful model. And we're doing testing to see what a greater than 85% overlap and side lap can do for us and a closer picture. We're getting to that more and more.
Yeah, and the really cool thing, or the aircraft we used for this one was the X2 Enterprise, correct?
Yes, just the X2 color. We didn't.
Oh, the color. Okay, so it was the X2 color, and then we've had some questions about how many battery swaps did you have to do when you were doing that substation inspection?
So the substation I did in 3 different scans. I made sure, of course, you want to have your landing box in the same spot for the entirety of all the scans. But specifically for each scan, you want that box in the same spot. It's not as crucial whenever you move to a new scan. So we did the high side as one scan, and I can switch back over to that substation.
Mm-hmm.
We did this high side as one scan, and it's a 3D tower scan. It's not the regular 3D scan, a 3D tower, because the tower scan really finds these lattice structures really well. So we're able to get those a lot better with it. And it finds each of these as a pillar and does that. And then the crossbeam here also is a pillar. And then we did the transformer as one and the low side as one. And the high side, I believe, took 2 batteries, 2 switches, or no, 2 batteries, 1 switch. So we started with full battery, switched once, and used most of the next one. The transformer and the breaker here in the middle took one battery. It may not even, the reason why I say it questioning like that, it may have been the one that was left over from the high side. And I'm not 100% on that. But it only took 1 for that, and then 2 again for the low side. And we're able to get down into the entire low side and take pictures of all of it as well.
That's pretty cool. And we had a question about the metadata that's captured. The metadata that's captured when taking photos with the Skydio products can be pushed into whatever your 3D mapping solution is, whether it's Drone Deploy, GNext, Pix4D, whatever you use, it can be used, and Esri Site Scan as well.
And I know GNext and Skydio have now partnered even closer, I believe.
Mm-hmm.
And now your models, when you put them into GNext, will go directly to the Skydio cloud or vice versa. We haven't gotten to that yet, but it's a relatively new thing. But I think that's kind of what they're talking about there.
Yeah, so basically, just to clarify that point, right? Like Skydio is software agnostic when it comes to the photogrammetry softwares you can use. So just like Corey just said, the 3D scan is Skydio's software to collect the images. So here, to clarify, when Levi's saying, hey, I did 3 different scans, he's going out there and he's doing 3 different missions or scans to collect the photos for the high side, the middle, and then the low side on the right side of this, right? So essentially, you were doing 3 or 4 different missions in the field, collecting all of those photos, and now you have those couple hundred photos that are on the SD cards of the drone. You're taking that, and those photos each have the metadata required to process those photos into a point cloud or a mesh in a photogrammetry specific software. In this example, we're using GNext Labs, but you could have also used Drone Deploy, Pix4D, Site Scan, the plethora of other ones that are out there, Bentley's Context Capture, etc. But we just happen to be using GNext Lab because that's what Levi uses at Arkansas Valley Electric Co-op.
Yeah,
so I clarifies that for the folks out there.
The Skydio also produces, with every 3D scan, produces a CSV file of all of that metadata as well, if your software needs that. Our GNext does not. I'm literally able to take all 3 scans, shove all of the photos in at one time, and hit upload and process, and it does it all for me.
Yeah.
I never have to do any of that.
To clarify, that CSV file is very specific for use in Pix4D. So it would help Pix4D process even better. But like you said, you don't need that here for GNext Labs. GNext is a cloud-based solution. They are a tech partner for Skydio, and they're what Levi uses. So that's what we're showing off here in this webinar.
So we had a question about a thermal capability of Skydio drones. This particular capture was done with the X2 color, so it did not have a thermal camera. But OnGuard, could you talk a little bit about thermal capabilities of Skydio?
Sure, absolutely. So we had a couple of questions, just like Corey said, about the different drones that Skydio has, right? Skydio has two different main models of drone. We have the S2 Plus, which is a bit smaller. It just has a color camera or an RGB camera. And then we have the X2, right? The X2 is our enterprise level product. It has the folding arms. It has three props instead of two props because it's quieter in the air. It's NDAA compliant, which means it fits a lot of the, compliance requirements for, American product, et cetera. It's what the federal government has chosen as their drone of choice. It's what the DoD is using, and it's what the drone that was used in the video here. The X2, right? Think of X as expert or enterprise. That X2 product that Skydio has, our drone, 35 minutes of flight time. It comes in two different camera configurations. It comes in the color version, which is the same camera as on the S2 Plus drone. So that's just a wider angle view RGB camera that is optimized for this 3D scan and better for close-up photos and inspection applications. But the X2 also comes in a variant of camera where it has a color, so an RGB camera, as well as a thermal camera. But think about that gimbal, that sensor plane is the same size on the X2 color and the X2 color thermal. So when we have the X2 color thermal, the one with the RGB and the thermal camera, the field of view of the RGB camera is a bit smaller because we have to fit two cameras on the same size gimbal. So here, that's why Levi and a lot of our utility customers are primarily choosing the X2E color because the field of view of the camera is bigger and it's better for inspection and close-up photos. But to talk specific to thermal, yes, you could have used an X2E color thermal and gotten those thermal photos as well. You can do the inspections in thermal. I think, Corey and Levi, if we want to talk about, I think Corey may have a bit more experience with thermal inspections here, but thermal is a fantastic way of seeing when a piece of equipment is getting towards end of life, or when it's hotter. Typically that's indicative of something going wrong within that piece of equipment. You can produce thermal point clouds or thermal maps. However, many times in that photogrammetry process where you take all those thermal photos and then apply the photogrammetry algorithms to make the 3D model, it loses some data. And this is obviously a pretty technical topic, and email questions, or I'm happy to have a conversation with you about the technicals of making 3D models with thermal imagery. But the reality is that it's better just to use the flat photo. And in this case, no, I don't think, Levi, you don't have a thermal capability on your drone. It's not here. So maybe, Corey, if you want to just touch on it, you use thermal in the field. Where's the benefit? And in this use case, is it really needed or not? What do you think?
Well, yeah, I think inspecting your switches, arresters, connections, that kind of thing with thermal is super valuable. To allow you to see like a difference of temperature, to give you an indication, to make a more, in-depth thermographic assessment of what's going on. We've found problems with switches, with arresters. You could, polymer arresters or ceramic arresters are able to see the difference in temperatures there and identify problems. Somebody had a question about the operating envelope of the X2, and from what I understand, the operating envelope temperature-wise is 14 degrees Fahrenheit to 104 degrees Fahrenheit. And those are ambient temperatures, and the drone will perform in all of those in that environment. Let's see what other photos or
I was going to add to the
the
thermal part of it. We do thermal inspections as well with drones. We don't for this use case specifically because it's better to look at them, like you say, with a flat image a lot of times. But GNext does have a thermal capability on their models, and we've not investigated the 3D modeling with thermal yet. But we find thermal very helpful on, like he said, switches or any point of connection can be an issue. So it's always good to look at that kind of stuff thermal-wise.
You know,
All right, we had a question about are there perspectives that the drone captures that you couldn't see before? Like we talked about those. I'll let you talk through that on the insulators, Levi.
Yeah, I'm not sure on that model exactly if I could find one right away. But with the Skydio's capability of looking directly up with that gimbal, we can see the bottom side of insulators and the top side. But we talked about it earlier. Whenever we're doing just regular inspections on poles and things like that, the ground inspections aren't finding things that you're going to see from above ever. And you're going to be able to see tracking, you're going to be able to see cracked insulators or maybe a hollowed out pole or something like that. So that offers a different perspective. Is that answering the question?
Yeah. Or maybe see that flash mark that's on the top of the insulator that you couldn't see from the ground, indicating like a failed insulator.
Yeah, or the pins, like we pointed out in a couple of the different situations, the cotter pins being taken out or falling out. Those you're not going to see very easily from the ground. You may get binoculars and see them, but they're pretty small up there.
Yeah. So we had a question about the docking station for the Skydio X2. There is a dock solution. Maybe OnGuard, could you talk through the dock and dock-based inspection?
Yeah, absolutely. I think that a lot of folks here, you may have seen Dock Day. Obviously, Skydio has made tremendous waves in the industry for being one of the first companies to come out with a commercially viable dock solution. For those of you who don't know, think of the dock as like a little doghouse for your drone. And so your drone, it lives in this little box, this home, this dock that charges it and is connected to the internet and allows that drone to go out, do a mission, and come back, right? And obviously, Levi, we've had many discussions about the future of where your program's going at Arkansas Valley Electric Co-op. And essentially, the way that this is working is today you're going out there and you're doing the substation inspection. You're taking that drone out of the box and you're setting up that 3D scan. But if this was something that, and I mean, okay, just to ask a question, Levi, really quickly, how often do you 3D scan the substation?
So currently we're trying to do them more often. We had another project that came up that's inspecting pole tops that we're doing more. But what I'd like to do is at least, so we have 36 substations, so at least every substation once a year. Now, more frequently as a dock purpose, I would love to do it monthly, weekly, because the drone can sit there. And once you get that BVLOS, which I believe you guys have a system that works with people to acquire that, and specifically in a substation, saying, okay, we're restrained to this area only, and we're only going to fly at these times and things like that. I think I would do even weekly inspections of substations if I had a dock at a substation.
So essentially what you're saying is you wanted to do some of these substations, maybe some of the really important substations where that power is going to a bigger community, and there's a lot of people downrange from where that energy is being produced. If that's something that you want to be doing at a very repetitive interval, once a week, or maybe even more than that, today a human has to go out there and take out that drone and scan that. That's labor to get out there. That's an individual's time. Obviously you're a GIS analyst and you have a lot of other work to do, right? But what makes you more efficient, if you know it's a repetitive task, is to have a docked drone at that substation where now you can do this type of work, but the drone flight and the image collection process will be done by itself. So you could put a Skydio dock in that substation, and this drone could once a week or once a day or at whatever interval you wanted, take off, do the whole automated scan by itself, come back home into its dock, recharge its batteries. It's connected to the internet. All those photos will be uploaded via the cloud to you so that you can then process that in GNext Labs or whatever other solution you want. And something else that Levi just said was he talked about this waiver process, right? Obviously, a drone flying by itself out there in the real world, that is under the control of the FAA outside. So Skydio has an amazing regulatory team that we have in-house where they will apply for those waivers and they will help our end users make sure that they're doing everything legally and everything absolutely correct in regards to airspace and permissions and flying under different waiver processes, et cetera, because now the human that has that typical Part 107 license is now out of the loop with the drop-down solution. So that's essentially what Levi was saying is Skydio will get you the waivers, it'll give you the dock, it'll put the drone out there, and now you can do these repetitive tasks over and over without a human in the loop. And it's making your company more effective and more efficient. And that's the future of where we're going, right? That's not what you're doing today, but it's where you want to go.
Yeah.
Well, and I think it's important too when you're talking about a dock-based solution inside of a substation that one dock installed at one substation can have multiple multiple use cases, right? You could have a security use case performing randomized perimeter patrols. You could do your routine inspection. You could do a event-based inspection. For instance, if there was a differential at the station, you could have the dock pre-planned with a differential with the differential scheme pre-programmed as a mission, and the differential happens, the dock launches, and then the drone inspects all the different components associated with that differential scheme. So I think it would be or it's important to note that one dock can have multiple use cases inside of a substation or transmission line or other facility.
Absolutely. I think this is the great time to let's kind of go through the questions that have come in, and folks can keep bringing them in. So I'll read them out and give them to either Corey or Levi to answer, and just as well, so everyone knows, all of your questions are going to be answered. We'll follow up after the webinar. We'll get you in contact with the right person. You can have a technical conversation. If you want, my direct email is right there on the slide, ungad@skydio.com. You can reach out to me directly and we'll get those answers, questions answered. And if you want to talk to Corey, who has more real world experience than I am, we'll get him on the phone. You can holler at Corey and go through this as well. So let's kind of go through some of these questions that have been brought in. So we answered the question of the product that Levi's using. He's using the X2E color. On the slide, you actually have the thermal version. You can see there's 2 camera lenses on that gimbal, but in his process for this purpose of producing his 3D scans, he's just using the X2E color with a 35-minute flight time. I think, Jared from a UAV pilot out there at an electric co-op was asking about the segmentations of the scan. We addressed that, right? That he went out there and he was doing multiple scans. Obviously, the image collection process of that asset, if the flight time's 35 minutes, you're really only able to collect enough photos for one battery. Come back home, switch out the battery, it'll restart and go back to continue. We addressed a lot of questions in regards to thermal, and actually this is really practical, right? Because this is a question. The question is, what does your workflow from image to repair look like? I would love Levi to answer this one, and then Corey, if you want to talk about what this looked like at Southern, that would be fantastic, because we're not just doing these inspections in a silo, right? They're not just done because they're cool. They have real world impact, and they impact the efficiency of your company, and they're adding to that workflow. So Levi, after you do this type of inspection, you find, a problem. What's the workflow to repair look like?
So if we're ever looking for problems, which we usually want to look for problems in these situations, we're going to bring it back, of course, process the data, and then an engineer or a sub-tech or whoever is determined to be the person to say, yes, that's a problem, something like that. We'll bring it into GNX, and then we can review photos, and we can actually mark each photo as reviewed or not reviewed or a problem. And then we can print out or PDF. We typically don't print out. We do mostly electronic, but can PDF a list of all of the annotations, all the issues and everything like that. Then that can be given to our, whether it be servicemen or construction crew, sub-tech, whoever's going to be doing the repairs, and they can schedule their timing on how they need to shut down whatever it may be to repair it, if it's something that has to be shut down to be repaired. Specifically on a substation, you don't want to work on a substation hot without grounding and all the different things that are needed just to get that done. So it's a really streamlined process, since we're able to take these straight into that if needed.
And Corey, similar process?
What were you going to say?
I was saying, did it look like a similar process when you were doing this in the field?
Yeah. The cool thing about Skydio drones is that you can get the drone in the hand of the subject matter expert. So that line line person or the engineer that is doing the inspection can be the decision maker. So, the drone being just a tool in their toolbox, in like complementing their years of experience on the line or in the substation, that provided a lot of value to us to allow us to communicate, via traditional methods, but really just capture photos of the defects as we found them. We had a question about the docks having climate control, and our docks do have climate control. We'll have to get back to you on exactly the I guess the temperature decrease on the inside of the dock and that kind of thing, but they are climate controlled to maintain the battery's ability to charge.
Super cool. We had another question here regarding that production of that photogrammetry model. Again, the question was, what does the process look like for merging the scans together into one model? And so my assumption, and Levi, tell me if I'm wrong, is you're doing multiple scans, right? Or multiple image collection missions. You're taking all those photos, dumping them into one folder, and then processing them all at once, right? Or are you doing it in segments?
Yeah, so I don't even have to put them into one folder. With GNext, I can switch between folders on my file explorer and drag them directly in. So I can say, here's this one, here's this one, here's this one. And it just knows to put them all together because it has the metadata from all of those photos and that they all fit together. It does work better if you have a connecting element. So the transformer is in the substation was that connecting element between those scans because it was a midpoint. And there was pieces of that transformer collected from both of them, or from all three of them. So it connects them all together. And that's the best case to do it that way. So I lost my train of thought there. But the process is super simple. Just the 3 flights, like you say, all at one time, or not one, one right after the other from the exact same spot, bring them in. You can put them into one folder together or not. It does not matter. The Skydio separates them into separate folders, which I like a lot because it keeps everything clean and nice. And then you may want to keep it that way even more so if you're using something like Pix4D, because that CSV file is going to be really crucial to those specific folder or photos. So I keep them separate, and I just take those photos, drag them directly in, hit upload and process, and it's ready to go. I can do them all at one time. There's not a segmentation to it whatsoever.
Hey, Levi, I got a question for you. How are you guys determining when you want to do a 3D scan on a pole versus when you want to do, just a few photos of the pole? Is it based off the equipment of the pole? Tell us a little bit about that.
Depends on the use case for what engineering is needing at the time. Mm-hmm. So typically, we most often just do regular photos. But here lately, our engineers have been going back, redoing, like I said earlier, the spec sheets. Even for a 3-pot transformer bank, I've scanned 4 or 5 of those in the last month, just to get really good scans so they can say, yeah, that's my measurement that I needed for that, and just re-verify themselves all the way through that process. So I would say more often just plain pictures, but the Skydio still, you never have to worry about hitting a line. So it's incredible in just the manual mode to do that.
That's pretty cool. And OnGuard, could you talk a little bit about wind speed limitations for that inspection imaging?
Yeah, actually, off the top of my head, I don't know the exact wind speed test, but I know that if you go through Skydio's social media or LinkedIn, you'll see a lot of videos of engineers testing that wind speed. So in my experience, the drone's smart, right? Skydio drones are AI powered. They're intelligent. They're making on the edge decisions, which basically means that drone, because of its vision-based navigation and its cameras and its computer, is making a lot of decisions and giving the pilot information that a lot of other products don't have on that market, right? I mean, Skydio is smart. So I know that when I've been flying my drone in very high wind conditions, the drone on my controller will tell me, wind is very high, please land. And so that is something to keep in mind as well, is that the drone's providing you feedback, which also reduces stress on the operator, right? Like Corey said earlier, when you were, leading your drone program, you would give the drone to the experts, to the engineers and the technicians who had years of experience doing that work. One of the reasons you can do that easier with Skydio is because Skydio is smart. It's easier to use. arguably maybe the easiest drone in the world to fly. And so the training time for folks is a lot less, right? At Skydio, we talk about autonomy, and what that autonomy is really doing for the end user is giving them a product that's a lot easier to use, provides more feedback so that you can make safer decisions and you can be less stressed out. Or, for our DoD federal customers, what we say is it reduces cognitive load on the operator. So, for example, high wind, drone will tell you, hey man, it's high wind. Let's bring this thing home. Let's get it a little bit lower. Or if it is too hot, it'll tell you that. If the navigation cameras have dust or there's stuff on top of it that's getting in the way, it'll tell you, please land and clean the lenses on the navigation cameras so that it can fly appropriately. So I apologize for not knowing the exact fact off the top of my head. I'm sure I can get that to the question out there for the exact wind speed that we've tested it at, but also know that the drone will tell you if it's too high of wind speed and you got to bring it home. So that's something to keep in mind, right?
For the substation scan, we chose a particularly not windy day because it's the first substation we had ever done. But it's been windy whenever we've done other pole scans and never not really had an issue with it. We even had we're training a new pilot, and she her first time ever flying a drone was with the Skydio, and she scanned a transmission pole.
That's pretty cool.
Yeah, usually when I do demos of this product in the field or I'm working with customers, I'll take the person that has never flown a drone before
Yes.
and who looks the most nervous, and I will tell them, you're going to fly this thing. They'll be like, no, I don't want to do that. No. And I'm like, no, come on, you can do this. Don't worry. Take the controller and I'll walk you through it. And they're flying it and they're comfortable. My 96-year-old grandfather, I've been doing drones for 10 plus years, and he never would touch any of the equipment that I would get excited about and want to fly. But with a Skydio, he flew it. That was amazing to me because it's so easy. And on top of it, that AI is avoiding things, right? I mean, we've seen that with the tower scan video. The first thing I do when I'm doing a demo of this for someone that's never flown a Skydio is I tell them, fly it right. I shouldn't say at me for, safety reasons, but fly it at that wall, right? Fly it at that concrete wall. And they'll be like, what do you mean? I'm like, no, take the stick and go as fast as you can into the concrete wall. And the autonomy on board, it builds that 3-foot safety bubble. And that bubble doesn't let it get too much closer. I mean, obviously there's things that will affect the autonomy, and it can crash, right? You have to be careful. You have to be careful out there. But for the most part, you can fly it directly into a wall and the autonomy will stop it. The drone will say, hey, I'm getting close to an obstacle, and the obstacle avoidance will stop that drone and not allow you to hit that wall. And that's really cool. And that's what makes it so much easier to use in the field for end users. And one of the reasons that I think, Levi, at your organization, you chose Skydio because of some of these things, right?
Yeah, and I'll never forget one of the first things our rep said to us: try and wreck it. See if you can wreck it right now. And it was Ben Grissett.
Ben Grissett.
Yeah, he told us, hey, try and wreck it. And we just looked at him. What are you talking about? And went right at a pole, went right around it. No problems.
You have to be careful because one of those times it will wreck. So,
Yeah.
we don't want to be too cocky about it. The AI is absolutely amazing. It's very powerful. It's on the cutting edge, but it's still in a piece of equipment that.
Yeah. No, we knew we weren't going to fly full speed by any means of that, but it's kind of like, okay, let's go towards it, see what it does, see if it sees this. And it doesn't have the same blind spots that a lot of the other drones do. A lot of them have them at their propellers, and that's a really bad place to have a blind spot.
Mm-hmm.
So we had a question in the chat about waivers for docks. Like Skydio has like some regulatory services built in or not built in, but we have regulatory services that kind of aid people in obtaining waivers for remote operations of docks. OnGuard, could you kind of explain that a little bit?
There have definitely been a lot of questions about regulations and waivers, and I'll say that Skydio does have an industry-leading team and has been at the forefront of producing a lot of these waivers, like the tactical BV loss waiver, or the getting organizations like NCDOT BV loss waivers. Beyond visual line of sight basically means the drone's farther away, you can't really see it, right? So typically under Part 107 rules, you want to be able to see that piece of equipment. But let's say that you're flying a substation or a building and you go around the back of it, or now you can't see that piece of equipment, that drone. At that point, you need to be careful, right? So Skydio's regulatory team, and with Doc, it's part of that onboarding process. We will ask exactly where you want to do that mission, How often do you want to do that mission? What is the purpose of this mission? We'll ask very in-depth questions so that our regulatory team can go to the FAA, help your organization, partner with your organization to make sure that we have all the right information. We're giving all that information to the regulatory authorities, and that you're operating these drones in appropriate ways in the airspace. And yes, it's different to where you're flying in different situations. I mean, if you're closer to an airport, it may be a slightly longer regulatory process to get that approval. But if you're out there in the middle of nowhere, it may be different, right? If you're flying over people, it may be different. So I know I'm not answering this in specifics, and there's a reason for that. Because sometimes with the regulatory aspects, there aren't clear-cut situations. It depends exactly on where you're flying, what you're doing, what equipment, and when. And so that's what our regulatory team is here to do, to make sure that we're doing everything properly and following the rules. And at Skydio, as a company, we're very, very careful to make sure that everything's done appropriately, effectively, and efficiently. So definitely, we've had amazing questions. I mean, I'm very impressed with the level of questions. I really appreciate, Levi for being our guest speaker today, and obviously Corey for being my co-host and knowing more than I do in regards to this topic. So what we're going to do is, we have your names, we have your contact information. We will reach out, and we'll answer those questions that were gone unanswered. So don't hesitate to reach out to me directly, ungood@skydio.com, or to respond to that email that you're going to get from us, because we want to answer your questions and we want to have discussions and get on the phone. And hell, if you want us to come out and do a demo, we'll do that. We'll come out to you, we'll do a demo, and we'll show you this equipment. And you can make your own narrative and your own story and your own cutting edge workflows, just like Levi has at Arkansas Valley Electric Co-op. So with that, I think we have 1 minute left. If Corey or Levi, you got anything left to say?
I don't. I'm happy to be using Skydio and happy to be able to do this.
Absolutely. Well, we appreciate you being out there and being an advocate for the technology, and not only telling us the good things, but also telling us where we can get better. That's really, really important. So with that, Corey?
Yeah, I appreciate everybody's time today and giving us the opportunity to share Levi's story. And I really appreciate the questions and interactions. And like Angad said, we're going to we'll follow up on the ones we didn't get to during the session here. So
awesome.